Welcome to Electronic Geek. In this video, we are going to see about op-amps as comparator. We will see non-inverting comparator and inverting comparator. We will also design the circuit and we will verify our results by simulating the circuit using LTspice. Before starting, I just wanted to know as to which software is more used by you all. Is it OrCAD or is it LTspice? So from next time onwards, I'll make sure that I use that particular software only. So let's get started with comparators. So basically, a comparator is a circuit which will compare the voltage at these two input terminals and it will produce the output accordingly. So in this video, I'm going to demonstrate this op-amp as comparator using IC LM741. Op-amps as comparator is a non-linear application of op-amps. Non-linear because the output is only going to have two states, either positive saturation or negative saturation. So this op-amp as comparator is used in an open loop configuration, which means that no feedback resistors will be used. So the output equation when op-amp is used in open loop configuration is V plus minus V minus into the open loop gain, which means voltage applied at this non-inverting terminal minus voltage applied at this inverting terminal multiplied by the open loop gain of op-amp. For LM741, the open loop gain is 2 lakh. So let's see how we can design a non-inverting comparator. So the first thing that is important is we have to give plus 15 and minus 15 to this IC in order to operate. So what we will do is we will take the voltage source, okay, placing it, then use a wire to connect them. So there will be a common ground, okay, and it will be connected over here. So I will have to set this voltage. So this is 15 volts. This is also 15 volts. And now I can either use net labels to connect these two terminals or I can directly do it with wire. So I'll move this. I'm doing with a wire. So they're connected like this and I'm done. The first configuration that we are going to see is of non-inverting comparator. So what happens in non-inverting comparator is when the voltage that is applied at this non-inverting terminal is more than the reference set at this inverting terminal, the output goes to plus V saturation. The reason being, suppose that I have grounded this inverting terminal, then the output will be given by V plus, so the voltage that I apply there, minus V minus is 0, so it will be V plus into open loop gain. So the output will be saturated by these plus 15 and minus 15 volts. Thus I will be getting a positive saturated output. So let's try this. So I will use a voltage source, okay, and I will connect it. Let's generate a sine wave. Go over here. I'll set the DC offset to 0. I'll keep the amplitude as 2 volts, frequency as 1 kilohertz. I'll click OK and it has been placed. And this minus terminal will be connected to ground like this. Now, let's set this reference to 0 volts. So I will connect it to ground. So yes, so whenever this sine wave crosses 0 volts, I will be having positive output, okay, a positively saturated output, which means my output will be near to 14 volts or something. So let's simulate this. I will keep the stop time as 10 milliseconds. So this is our input signal, okay, and this is our output. So see, whenever this is going more than 0, we are having a positively saturated output. Now again, as soon as this crosses 0 towards negative region, towards the negative half cycle, our output goes to negative saturation. It's all because of this. Our reference at inverting terminal is been grounded, and that's why the output is V plus into the open loop gain of this 741. So our output is going to be saturated and we will be having a square wave like this. Let's try by setting some reference. So I will remove this ground and I will connect a 1 volt source. So like this, like this, and I will keep the voltage at 1 volts. Now, what should happen is whenever this sine wave, okay, whenever this sine wave crosses 1 volt, our output should go to positive saturation. Let's run it. So this is our sine wave. This is 1 volt reference, and this is our output. See, as soon as this is crossing the reference, our output is getting positively saturated. So our output is in the positive saturation for this much time. Okay, when the sine wave voltage reduces from this positive 1 volt, for that particular time we are having negative saturation. Okay, so this is about non-inverting comparator. Now let's see about inverting comparator. So there is a slight change, okay, in both the configurations. Now this input signal will be applied to this inverting terminal and this reference will be now set at this non-inverting terminal. So let's make those few changes. This configuration is called as inverting comparator. Okay, so what will happen is whenever this sine wave is greater than 1 volt, our output is now going to be in the negative saturation region. Okay, it's completely opposite of what we saw in the non-inverting case. Whenever this sine wave is less than this reference, the output will be plus saturation. Okay, positive saturation. Let's simulate and see. So this is our input signal. This is the reference and this is the output. So you can clearly see that when the sine wave is having amplitude more than the reference, we are having a negatively saturated output, and whenever the sine wave is having voltage less than this set reference, we are having a positively saturated output. Now let's do a slight modification in this. Okay, we will remove this voltage source, and now the input has been grounded. So what will happen is that whenever this voltage is more than 0, we will having a negatively saturated output, and when it will be less than 0, we will be having a positively saturated output. So let's see, when it's less than 0, we are having a positively saturated output. When it's more, we are having a negatively saturated output. This circuit is called as a zero crossing detector circuit. So this is all about non-inverting and inverting comparators with and without references. So this is all about this video. Thank you for being till here. Thank you so much. Please do like, share and subscribe to my channel. If you have any doubts, suggestions or feedback, feel free to put them in the comment section. Thank you for being till here. Thank you so much.